my previous lecture, I have explained how to choose an attribute for the CART model. We know that there are three methods. One is information gain method, second one is gain ratio method, third one is Gini index. In previous lecture, I have explained by using gain ratio and Gini index how to choose an attributes, and I have explained all the procedures. In this lecture, we are going to use Python. With the help of Python, we are going to construct the CART model. Then I am going to explain the decision tree. Then I am going to interpret the output of CART model. This was the sample data. This is an example. Say there are variable age, income, student, credit rating is the attributes for independent variable. The dependent variable is buys underscore computer. This example is taken from this source, Hand, Pay and Comber. The title of the book is Data Mining Concepts and Techniques. I have brought the screenshot of, first we will import relevant libraries and loading the data file. This file I have copied into the Excel. So, I am importing pandas as PD, import numpy as NP, import matplotlib.pyplot as PLT. I have imported the data, then stored any object called data. Then there are different methods for encoding the data. The first one is label encoder. This method is used to normalize labels. It can also be used to transform non-numerical labels into numerical labels. In our examples, the data are non-numerical, that we are going to convert into numerical labels. The another function is fit underscore transform. This method is used for fitting label encoder and return encoded labels. So, this is a data encoding procedures. We import sklearn, from sklearn dot pre-processing import label encoder. So, LE underscore age label encoder, LE underscore income, like that for all the variables. Now, there are different attributes like age, but age, income, student, credit rating, buys computer, this is in the text form. So, that I am going to convert into numerical form. That new variable is age underscore n. By using this function LE underscore age dot fit underscore transformation. You see that wherever there is a fit underscore transformation, that is a text data is going to convert into numerical form. Now, what is happening is this portion is the text. By using transformations, I have converted into the numerical form. Then structuring the data frame by using the function drop. This is used to remove rows or columns by specifying label names and corresponding axis, or by specifying directly index or column names. So, what we are going to do? In the previous slides, I told you there is a text data also is there are numerical data is there. Since already we have transformed into numericals, that the text portions that I am going to drop it by using this drop function. So, after that, this was the my data set. In this there is no text, only numerical values. So, this data set is going to be taken for building the CART model. In the building the CART model, we have to specify what is the independent and dependent variables. We know that dependent variable is buys underscore computer, the independent variable is age, income, student, credit rating. You see that I am using age underscore n, that is in the numerical form. In the dependent variables, only two options, yes or no, that is buys underscore computer underscore n, that has only two levels, one is 0 or 1, that is yes or no. Now, we are going to build the decision tree model without splitting. What is the meaning of without splitting is, in data mining, whenever the huge amount data is there, some data set should be used for training the model, the remaining data set should be used for testing the model. Now, we are not going to do that way, we are going to take all the data set for build the model, we are not going to test the model. From sklearn.tree import decision tree classifier, CLF equal to decision tree classifier, DT equal to CLF dot fit XY. This was the DT, this was the output. Now, we are going to visualize the decision tree. From sklearn.tree import export graph viz. From sklearn.externals.6 import string IO. From ipython.display import image, then import py.plus. So dot underscore data equal to string io export underscore graph. This was the commands for getting the graphical output of our cart model. Then I have specified what is the dependent variable. This is the output of our cart model, that is a decision tree. This stage, let us understand how to interpret this. When age underscore n is less than or equal to 0.5, there are two possibilities, it is a true and false. I will explain meaning of this 0.5 in the next slides. So whenever is a true, whenever this blue box represents, it is a favorable decision for us. For example, orange color box represents is unfavorable. What is unfavorable? That person will not buy the computer. That is a class 0. If it is a class 1 means that that person will buys the computer. Suppose if you want to interpret this blue box, how to interpret this? First look for the age. Age, we have seen there are different levels in age. If it is a true, that person surely will buy the computer. If it is a false, then look for the student. In the student also there is a two possibility, yes or no. This is a true, this is false. When you go for student, when this condition is failed, you will go for false, then you will look for another attributes credit rating, then it is a true, this is false. In the credit rating, when the false condition appears, then this is favorable decision. If it is a true, you look for another attribute income. In that income, if the false is applicable, then it is a favorable decision for us. So I will explain each values in the box and the meaning of the different color coding in coming slides. Let us interpret the cart output. This was the data which I have taken. We first use the following equation for Gini index to compute the impurity of D. This also I have explained. We know that formula Gini D is 1 minus sigma of I equal to 1 to m pi square. M is number of levels in our dependent variable. Here the m equal to 2 because yes or no. So Gini index equal to 1 minus, the 9 represents how many yes? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 yes out of 14 minus this 5 represents number of no's. So 5 divided by 14 whole square, this is 0.459 is the Gini index for our dependent variable. So D represents the dependent variable. Now let us take one attribute at this stage. Suppose I have taken income. Income is our attribute. We are going to use Gini index for this attribute. We know Gini index always go for binary classification. There are 3 levels, low, medium, high. Option 1 is we can group into 2 way because it is a binary classification. Low, medium is one group, high is another group. Next, high, medium is one group, low is another group. The last choice is high and low is one group, medium is another group. For all these 3 combinations, let us find out what is the Gini index. First we will take low and medium. In the low and medium, we have to look at how many people answered yes. 1, no not this one, 2, 3, that is why we got this 3. When it is a medium, how many people were answered yes for our dependent variable. So this is 1, this is 2, this is 3, this is 4. So 3 plus 4. In the same way, when it is low, how many people answered no? This case 1, only one option is there, low and no. Then the second case, when it is medium, how many people answered no? Medium and no, this is 1, then this is 2. So 7 and 3. That is why we got this table. This is one group, part D1. Actually what is happening here? So, the income variable we are going to go for binary classification, one is D1, another one is D2. In D1 we are going to consider the two levels, low and medium. In the another group we are going to consider only high. So, that is why D1 is low and medium. So, the D2 is only high. So, that is D2, it is a high. How many people are answered when it is a high? How many people are answered yes? This is 1, high yes 2. So, when it is a high, how many people answered no? This 1, high no 2, yes this is 2. Now, we are going to do the Gini index for income attributes. The Gini index value computed based on this partitioning is, so Gini income belongs to low and medium. So, 10 divided by 14, how we got this 10? When you count low and medium, there will be 10, count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that is a 10 divided by 14. Gini D1, the formula is 1 minus 7 by 10 whole square minus 3 by 10 whole square. The second option for the D2, 4 by 14. How we got the 4? When it is a high, we have to count it how many high is there in the income, 1, 2, 3, 4. So, 4 by 14 Gini D2. D2 is 1 minus, because number of yes and number of no's are same, 1 minus 2 by 4 whole square minus 2 by 4 whole square. So, this is the Gini index for low and medium, that is 0.443, that is equivalent to Gini index for other level high. The Gini index value for the another option, what is that another option? So, there are two options, option 1 D1, D2, this is D1, this is D2. In D1 high and medium is there, in D2 low is there. So, when you having this 2 split, the Gini index for income attributes which is belongs to, that is a high and medium, we are getting the 0.45. The third option is high and low is one group, high and low is one group, then medium is another group. The same way when you continue, we are getting the Gini index is 0.4. Now, by comparing all the combinations, so the lowest Gini index value is this one, 0.443, that is for when income is high. Now, the Gini index for age attribute, so Gini index for senior it is 0.457, for middle age it is 0.357, for youth it is 0.393. The lowest Gini value is this one, that is 0.357. Similarly, we will take another attribute, that attribute is student. So, for student attribute also, when you find the Gini index it is 0.367. The next attribute is the credit rating. For this the Gini index is 0.428. Now, when you bring all the Gini index for different attributes, the age one is having the least Gini score, that is 0.357. This attribute should be chosen for the classification, that is the preference should be given for age. So, the attribute with the minimum Gini score will be taken, that is the age, because that Gini index is 0.357. When you go for age, there are 3 levels there, middle age, youth and senior. When you look at middle age, they have answered yes for buying, all people have answered yes for buying computers, with that we can stop it. Now there are youth and senior, then we have to continue, which attribute has to be chosen for here. So, since all the middle age people have answered yes, see that middle age is yes, yes, yes. Now, the next calculations, we are going to drop these rows. After dropping these rows, again we are going to find out the Gini index. So, after separating these 4 samples belonging to middle age, total 10 hours are remaining out of 14. So, for that 10 rows we are finding Gini index for our dependent variable 0.5, Gini index for age is 0.48, Gini index for credit rating is 0.41, for student it is 0.32, for income it is 0.375. Again we have to look at which attribute is having the lowest Gini value. Take the student as node as it is having minimum Gini score. So, what we have to do after first priority is age, next we have to take student as a classifier. In the student there was a two level was there, yes and no. If the student says yes, then which attribute has to be chosen? If the student is no, then which attribute has to be chosen? We will see that. Now, what we have to do? Omit the marked rows either belonging age equal to middle aged or student equal to yes. So, wherever, so we are talking about here in which variable, which attribute has to be chosen. So, what we are going to do, if it is a middle age in the data set, if their middle age is there, that has to be dropped. If the students are answering, if the student level is yes, that also is going to be dropped. So, middle aged is dropped, wherever the student is the yes, that also dropped. So, how many we are going to drop? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, out of 14, 9 rows we are going to drop it. So, the remaining rows for further iteration is 5 rows. For that 5 rows, again we are going to find out the Gini index for the dependent variable 0.32, for age 0.2, for credit rating 0.267, for a student it is 0.32, for income it is 0.267. Again we have to look at which attribute is having the least Gini score. So, the age is having the least Gini score. When the student level is no, we have identified what is next attribute. Similarly, when the student level is yes, we have to find out what is the next attribute for further classification. For that, omit the marked rows either belonging age equal to middle aged or student equal to no. So, when you do that one, the remaining 5 rows are remaining. Using these 5 rows, again we are going to find out the Gini index for our dependent variable 0.32, for age 0.267, for credit rating it is 0.2, for student it is 0.32, for income it is 0.267. Again we have to look at which attribute is having minimum Gini index. So, the credit rating is having the minimum Gini index. What is to be done? So, the credit rating attribute has to be brought here for further classification. Like this, we have to continue to satisfy all the conditions. Now, I am going to explain the coding scheme, because this coding scheme is important if you are going to interpret the Python output for our CART model. There was one attribute called age, student, credit rating, income, buys computer. So, there are 4 independent variable, 1 dependent variable. Youth is coded as 2, middle age is 0, senior is 1. So, because this coding is important for interpreting the output. This was our Python output. Now, you look at the first variable is age underscore n. When it is less than 0.5, this Gini index we got it 0.459. When you go back, you see that this one. Whatever the value which are appearing in the Python output, we have manually solved it, so that you will feel more confidence. When age underscore n is less than 0.5, now you have to see what is the meaning of this 0.5. So, because we look at this the coding, the age is coded, youth is 2, middle age is 0, senior is 1. So, if n less than or equal to 0.5, that represents the middle age. That is why we got this one. When this condition is true, this is middle age. When the condition is false, they belongs to youth and senior. What is the meaning of this 5, 9? The 5 represents no, 9 represents yes. Since in the middle aged group, all are, see that 0, 4, all are answered yes. So, the first represents no, second represents yes, all are answered yes. So, we are not going for further classification. Then we are taking student underscore n as another attribute for further classification. When it is less than 0.5, we have to see what is less than 0.5, because student we have coded yes equal to 1, no equal to 0. When I say n is less than 0.5, that represents no. When the student is no, that is why when the condition is true, it is no. This is true, this is false. This is one branch. When it is yes, there is another branch. Then next we choose age underscore n less than or equal to 1.5, because now in the age only two group is there, one is youth and senior. When you go here, when is youth and senior is there, when n is less than or equal to 1.5, that represents the senior. Yeah. When the condition is true, that represents senior. When the condition is false, it is youth. We will go to the next one. When the credit rating underscore n is less than 0.5, there are two options. When the condition is true, it is excellent. How we got this excellent? Go to credit rating coding. Credit rating coding, fair represents 1, excellent represents 0. So when the condition is less than 0.5, it is excellent. When the condition is true, it is excellent. When the condition is false, it is fair. Then we will go for income underscore n less than or equal to 1.5. When the condition is true, high and low, how it is? Let us go for this coding. Income high equal to 0, low equal to 1, medium equal to 2. If it is 1.5, if n is less than 1.5, that represents low and medium. When the income underscore n is less than 1.5, what is the meaning? You look at this table. So when is less than 1.5, this group, this is less than 1.5 is high and low. So high and low is one group, medium is another group. So as a manager, how to interpret this? First the classifier is the age. If it is true, then go for middle age. The middle age people will have the positive response for buying the computer, that is why 1. If this condition fails, then go for the student. If they answer yes, then look for another attribute credit rating. If it is fair, there is favorable response. If it is excellent, we should go for further classification. When it is excellent, the next classifier is income. When the income, if it is a true, they belongs to high and low, then they will not buy the computer. When it is medium, then they will buy the computer. When we look at the left hand side, when the student n less than or equal to 5, it is no. Then we go for next attribute age, because age already we have dropped middle age, the remaining is the youth and senior. If it is true, it is senior. If it is false, it is youth. So if it is senior, then you have to look for credit rating. If it is youth, there is a not favorable response. So the 4 represents number of no's, 1 represents number of yes in our dependent variable. So and another thing is, look at the wherever the class is 1, there is only number of yes is there. See here that blue one, 0, 4 only yes is there, 1, 4 only yes is there, 0, 3 only yes is there, 0, 1 yes is there, here also 0, 1 yes is there. So the blue boxes are which will give you the favorite decision for us. The orange boxes, when you look at this, see that here there is no, see 1, 0 only no is there. Here also 1, 0 only no is there, here also 3, 0 only no is there. So the orange box represents it is not going to give our favorite decision. The white box represents that is an intermediate in the sense we have to go for choosing some more attributes for further conclusion. So what this 14 represents? Values for the dependent variable, there are 14. Then the samples represents the sample size and so on. So repeat the splitting process until we obtain all leaf nodes and the final output. The leaf node represents this one, this is leaf nodes. Now we have done the data without splitting, but in the data mining generally we used to split the data set. So we split the data set. So testing data set, 25% data is going to be used for testing, the remaining data set is for the training. So, you run the Python code what I told previously. So, here we are going to get the accuracy is 0.75. What is the meaning of this 0.75? Our classifier, this decision tree model, able to classify whether they are going to buy the computer or not with the 75% of accuracy. Then visualize the decision tree. So, what is happening? You see, when you are splitting the data set, now the node variable is changed. The node is student, previously it was age. So, what is happening? Since our data set is very only 14 data set, we are getting this different result. Now, I am going to explain the Python code for running the problem which I have explained. First, import the pandas as PD, then other libraries like NumPy, Matplotlib I have imported. Then I am going to import the data. The data, you know that there are age, income, student, credit rating, buys underscore computer. So, this is in the text form, but I have to encode this data because I want in the numerical form. I am encoding. Now, this shows that after encoding the right hand side, we are able to see the equivalent numerical values. Now, we are going to drop this text values because we are going to use only the numerical values for the building the cart model. So, this was only the numerical values because there is a 14 data set. Now, we are going to declare what are the independent variable, what are the dependent variable. So, the x, these are the independent variable. What are the independent variables there? Age, income, student, credit rating. Let us see what is the dependent variable. Dependent variable is buys underscore computer, that has two levels 0 and 1. Then I am building the decision tree model. For getting this output, you need to install these packages. This shows our cart output. So, age is the first attribute. When the age is true, then we are getting the leaf node, it is a false. Then we are choosing another two attributes. If it is a, then age, credit rating. Further we say credit rating, then we go for income. If it is a false, we are stopping. So, here what do you need to understand? The blue circle represents, the blue rectangle represents the favorable decision for us, the orange one represents the unfavorable, white one represents in between. That means we need to do further analysis. Now, we are going to split the data set, splitting the ratio of 75-25. So, 75% of data set is for training, remaining 25% is for testing. So, after splitting the data set, we are running the cart model. Then we are going to evaluate, that is accuracy of our model. So, the accuracy is 0.75. Now, we will visualize the cart model. This was the output of data set where we are doing the splitting. So, now the student is taken as the primary node for splitting. If it is a true, we will go for credit rating. If it is a false, we will go for age as the next classifier. Then age, then we go for the condition. If it is age underscore n is less than or equal to 1.5, I explained what is the meaning of 1.5. Everywhere there are more possibility of favorable decision because class equal to 1. There is a orange rectangles which represents 0, 0, which is not favorable decisions. So, what it means that when we split the data set, our decision making become very simple because our tree is in the very simple form, easy to interpret it. In this lecture, I have explained how to do the CART model with the help of Python. I have taken a sample problem. With the help of sample problem, first I have got the CART model without splitting the data set. After that, after splitting the data set, then I got the output, then I have compared. Then I have explained in detail the output of the CART model. With that, we are concluding this course, Data Analytics with Python. Thank you very much for attending this course. Thank you.